They've brought cellular phones, hundreds of channels of television, accurate weather reporting, mapping, navigation, space astronomy. All these things and dozens more have changed the world the satellites hover above. And much of the rocketry that puts the satellites there comes from the Lockheed Martin factory near Denver. It's one of the largest rocket factories in the world, making what are now the largest U.S. rockets, Titan 4Bs. These, along with the smaller Atlas and Centaur rockets, each hundreds of millions of dollars worth of precision equipment, are put together on an assembly line, just as if they were jet planes or Chevrolets. It takes about 3,000 people to make these rockets, but only about 200 are actually involved in their final assembly. Some of them working like surgeons in the so-called clean room. The upper stage Centaurs have to be clean because the satellites they carry really have to be clean. Any bit of dirt that lands on a lens or a mirror or in the inner workings will, in outer space, stay there for a satellite's lifetime, perhaps permanently impairing its performance. And this is the Titan, getting wired up. Titans are the workhorses of the U.S. rocket fleet, built to take the heaviest loads, up to 20 tons. Titan started life as a weapon, a ballistic missile. But its first space use was to launch humans, the Gemini missions, the preparation for the moon landing.
5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Today it's commercial, and though it costs about $300 million to make, each launch brings millions in profit. And launching satellites, like any big business, is international.
9, 8, 7, 6, 5, 4, 3, 2, 1, stop.
The European rocket fleet, Ariane, launched from French Guiana, carries most of the world's biggest commercial payloads.
24, 23, 22, 21.
The Japanese have H-2 rockets. They have plans for moon orbiters, a space shuttle, and a space station.
全システム準備完了。
5、4、
メインエンジンスタート。 SRB 点火、リフトオフ。
The closer a launching pad is to the equator, the less power is needed to get the rocket up, which is why Ariane goes from Guyana and the H-2 is launched from one of Japan's most southerly islands, subtropical Tanegashima, which makes it more fuel efficient than if it were launched from Tokyo. But what happens when a far northern country wants to get into the satellite business? Around the oil-rich North Sea, there are plenty of used drilling platforms, and now Norwegian, US, and Ukrainian companies have teamed up to convert a 31,000-ton platform into a launch pad to be towed to the equator. Rockets are assembled on the ship, transferred to the platform, winched up, pointed at the sky, and launched eastwards, parallel to the equator. The reason an equatorial launch saves fuel is that the planet turns fastest where it's the thickest, and the spinning speed of the globe there gives the rocket an extra boost. The rocket also has a shorter distance to reach geostationary orbit. In this orbit, 25,000 miles high, satellites travel around the Earth once every 24 hours. But when space stations are up and running, even cheaper rockets will be needed. Today's rockets are so expensive because they're used once and thrown away. Rockets regularly visiting space stations like this one will need to be reusable. And that was the original reason for building the space shuttle. Work on the shuttle started in 1972. It was supposed to ferry passengers and supplies into orbit, spend up to 3 weeks there, and then fly back to Earth like an airline. The shuttle's budget was tight, though, and didn't allow for all the necessary technology to be developed. And it was never entirely what it was meant to be, a simple, reusable spaceship. It now costs up to $500 million a launch. Even so, it's still a hell of a machine. And people who have seen a launch never forget it. To get all its 2,000 tons of dead weight off the ground, the shuttle relies on solid fuel packed inside the white boosters. Once high in the atmosphere, the huge external tank filled with liquid hydrogen takes over. The chief designer for this most intricate of machines is Max Faget.
Well, there's our shuttle. When it's all fueled up and ready to launch, it'll weigh almost 5 million pounds, which is a great deal more than we expected. The original idea was to have a vehicle that could carry astronauts up to the space station and back down, and perhaps a little bit of cargo. So it was designed to carry about 5,000 pounds, maybe a little bit more, with a crew of perhaps 6. However, as time went by, a lot more uses for the shuttle were invented, and it was decided that it should be able to carry as much as 60,000 pounds. And of course, that made the thing an awful lot bigger.
The shuttle is now the main source of human access to space. 10 or so are launched every year, each one carrying from 5 to 7 astronauts. 220 people, including 27 women, have been shuttled into orbit, and there have been 90 launches so far.
Main engine start. 3, 2, 1. 0.
Even so, this 1997 takeoff is the first that Max Faget, who worked at Houston Space Center, has ever seen in person. Riding upwards on a 600-foot trail of flame, the shuttle is a sight to behold.
Boy, that is bright. Super. That's the first time I've seen a launch since Al Shepard went to the moon. And it's just outstanding to listen to that noise. Of course, I've been watching them all on TV, which you can see a lot more, but to be here and see the thing live and hear that tremendous crackling roar of the launch, it's really been something else. And that's a great ship, I'll tell you. It doesn't meet everybody's requirements, but it's a super ship, and we're all proud of it.
The solid fuel boosters burn out in 2 minutes and are dropped into the sea, 160 miles from the launch pad. The shuttle is now powered only by the main engines. In 4 minutes, it empties the tank of 440,000 gallons. The tank will now break up. It's the only part of the operation that has to be wasted. As high as 370 miles up, the astronauts go to work. The shuttle crew can even pull up alongside satellites and repair them.
Sure did. About that. Are we in attitude?
Here, they're fitting eyeglasses on the faulty lenses of the Hubble telescope, a job that later helped astronomers see hundreds of things never seen before.
Final pre-clear maneuver of the
As amazing a vehicle as the shuttle is, there are elements of the 1972 jalopy about it. Its guidance computer, for instance, still uses cathode ray tubes, and the steel bearings in the oxygen turbo have to be replaced every second flight.